So today we'll be discussing about the factors that influence the rate of corrosion. We have already seen that corrosion, depending upon the environment, it changes. Like if you put a metallic rod in Delhi and the same metallic rod in Mumbai, then you can see the rod which is kept in Delhi lets it corrode in 3 months. Then the same rod in Mumbai it corrodes in 2 months. The reason is Mumbai has more humidity because it is in the coastal area, but Delhi is dry. So that's why the rate of corrosion is different in case of Delhi and Mumbai. So, this is what humidity is one of the factors. So similarly, we have so many factors which affects the rate of corrosion. So these are the two factors, right? So you can see these are the two factors which are responsible for corrosion. One is primary, another is secondary. In case of primary, it means it is the nature of metal which affects the rate of corrosion. And secondary is something which is not the metal but anything which is other than metal which is responsible for the increase in the rate of corrosion, right? In primary factors, the metal itself is responsible for different rate of corrosion, but in case of secondary, the environment is responsible for it. So one by one, let's discuss the primary factor and then we'll move on to secondary factor. So the first is nature of the metal and how it is affecting the rate of corrosion. Because we know the concept of corrosion is totally based on electrochemistry. And in electrochemistry, we already know all those metals which have less standard reduction potential act as anode. And if something acts as anode, then that's what there will be more and more corrosion. So in case a metal having less standard reduction potential will behave as more and more anodic, so rate of corrosion will be fast. So that's why we can see in the periodic table, the metal which is kept on the left hand side of the periodic table like alkali and alkaline, they are very fast in corrosion. In fact, they catches fire when they kept in air. Now the second point, the primary factor which is responsible for corrosion is electrode potential difference. This is very specific because this is what happened in galvanic corrosion. So how it works, if two metals are kept in contact, then the rate of corrosion depends on the electrode potential difference between the two electrodes, right? So if I say if the electrode potential difference is between the two electrodes are more, or between two metals are more, then the rate of corrosion, that is galvanic corrosion, will be faster. So iron will corrode faster in presence of tin. If it is, rather it is kept in contact with a metal which is having less difference, right? Third is surface state of the metal, this one. So in this case, if the surface is smooth, then the normal corrosion will take place. But if there is some pit on the surface, then it leads to pitting corrosion, which will increase the rate of corrosion. Last is formation of protective film by metal. This is an exceptional case. This doesn't happen in all the metals. It happens only in few metals. And one of the example of this is aluminium. Because in case of aluminium, once the first layer of oxidation happens, it forms a protective layer, which is alumina layer, which is very, very stable and it is non-porous in nature. So once the layer is formed, it cuts the supply of oxygen, and that's why the metal and oxygen doesn't come in contact. So that's why the rate of corrosion is decreased after that. So aluminium, which is having less E0 value, aluminium having a very less standard reduction potential, should be more and more corrosive, but due to the formation of this protective layer of alumina, it becomes passive. So this is also called passivity. So these are the all four factors which are responsible for